Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing quadratic applications, and in particular, the case of the Pythagorean theorem. So this video tackles problems that require using the Pythagorean theorem to create a quadratic equation and then solving it using the quadratic formula. So in this question, we have a triangle with sides x, 2x minus 3, and 6. And we are required to find an equation in x. Of course, since this is a right-angled triangle, we will use the Pythagorean theorem here. So we have 6, which is the hypotenuse. The hypotenuse of the Pythagorean theorem is the longest side of the triangle. It's also always opposite to the 90-degree angle. So the Pythagorean theorem says that this side is C, and this side is A, and this side is B. A and B do not matter. You could have switched A and B, but the important thing is to make sure you understand that C is the hypotenuse, which is the longest side. And the Pythagorean theorem simply states that C squared equals A squared plus B squared. So in this case, we have 6 squared equals x squared plus 2x minus 3 all squared. So 6 power 2 gives us 36. This is equal to x power 2 plus, and now you should be able to expand this bracket. For those of you who like to use the rule a squared plus 2ab plus b squared, that would work. I will do it in the more systematic and slower way for those who feel more comfortable with that. So I will not use the shortcut. So 2x times 2x is 4x power 2. 2x times negative 3 gives us negative 6x. Negative 3 times 2x gives us negative 6x again. Negative 3 times negative 3 gives us positive 9. So this becomes 4x squared minus 12x plus 9. And we write this down in the equation. So we have 4x power 2 minus 12x plus 9. And then we simplify and collect the like terms and so on. So we have 36 equals x power 2 plus 4x power 2 gives us 5x power 2. And then minus 12x plus 9. And we can always take the 36 to the other side. So it becomes 0 equals 5x power 2 minus 12x. And then plus 9 minus 36. 9 minus 36 gives us negative 27. So we have 5x squared minus 12x minus 27, and this is equal to 0. So this is how we solve question A, and of course we know that we're right. We don't even need to check the marking scheme because it's a show that question, and we got the exact same equation that they require. This is the equation that they want, and this is the equation that we got. Of course, some of you might be asking if it's okay to have the 0 on the left or on the right. It doesn't really matter. So you can always swap two sides of an equation. This does not change the value or the correctness of the equation. Next, we have question B, which says solve this equation, show all your working and give your answers correct to 2 decimal places. So if you're required to show your working, you cannot just use the calculator to find the final answers. This wouldn't work here. You have to use the quadratic formula. The quadratic formula says x equals, and I would recommend familiarizing yourself with the tempo I'm about to say, because this helps us memorize the formula more easily. So minus b plus minus root b squared minus 4ac all over 2a. This is the quadratic formula. Minus b plus minus root b squared minus 4ac all over 2a. So this should help with the memorization of the formula. Now, what are a, b, and c? So basically, the standard form of the quadratic equation is ax squared plus bx plus c equals to 0. So in order to get A, B, and C, we do something called comparing the coefficients. It sounds complicated, but it really isn't. You just write your equation underneath this equation here, and then you compare each number to the corresponding letter. So we have something next to the x power 2, and in this case, it's 5. So 5 is A. And then next to the x, we have negative 12. You have to take the signs into account, of course. So B equals negative 12. And finally, C equals negative 27. So we are ready to proceed and plug these values into the quadratic formula. So x is equal to minus B, or negative B, so negative 12. So this is just positive 12. Plus minus. So just to make sure that you understand, we have positive 12 here because it's supposed to be the negative of B. And B is negative 12. So negatives cancel out and we just get positive 12. So 12 plus minus root B squared. So B squared here is just this number raised to the power of 2. I just find it easier whenever I'm squaring something to ignore the negative, because negative 12 all power 2 is the same exactly as 12 power 2. And if you write it in the calculator like this, you're going to get negative 144, and this is incorrect. Because it's supposed to be either you write it in brackets or you just ignore the negative altogether, because the answer has to be positive 144 and not negative 144. So whenever you're squaring something, just ignore the negative so as not to fall into this trap. So B squared is 12 squared, which is 144, minus 4 multiplied by A, which is 5, multiplied by negative 27, and all of this is under the square root. And then all of this is divided by 2A, which is basically 2 times 5. I like to simplify things for myself. So, of course, here I know that I have 2 negatives. So these negatives cancel out, and we just get a positive sign here, just a plus here. And then 4 times 5 times positive 27, that's 540. So we have root of 144 plus 540. And outside we have 12 plus minus this answer over 10. And all you have to do now is just evaluate the value of x. I'm just going to use my calculator. Of course, you can just find the radical first, if that makes life easier. You can just type up radical 144 plus 540. And that gives you 26.15. So we can rewrite the equation as follows. X equals 12 plus minus 26.15 over 10. And this gives us two solutions that we can also get using the calculator. So 12 plus 26.15 is 38.15. So this is going to be 3.815 or 3.82. This is your final answer. And then you plug again 12 minus 26.15 divided by 10. And that gets us negative 1.415. Again, this would be negative 1.42. So your final answers for B are 3.82 and negative 1.42. I would suggest we check the marking scheme to make sure we are on the right track, and luckily we are. So these are the final answers here, 3.82 and negative 1.42. So let's go back and just write the final answers to clear some space. Of course, your answers here are both included, because in question B, there is no real-life application. You're just being asked to solve the equation. So if you solve an equation, you can get a negative answer, no problem. So we either have 3.82 or negative 1.42. These are the answers to B. For C, calculate the perimeter of the triangle. So of course, for C, now we have a real life application because we're trying to calculate the perimeter. And you cannot use the negative value in this case. So you have to go with the positive value. So in this case, X, so I'm solving C now, and X equals 3.82. So we have a triangle. And we have this side here, 3.82, and this side is 6. And here we have 2 times 3.82 minus 3. Of course, if you don't understand where this came from, I'm just applying the X here with the value that we obtained. So 2 times 3.82, this gives us 7.64 on the calculator, and then minus 3, this gives us 4.64. So the last side, the bottom side here is 4.64. And the parameter is basically the sum of the sides. So to get the parameter, you start at a point and you walk around the shape. So I'm just going to walk in this direction, and then followed by this direction, and followed by this direction. So this just means I'm adding these 3 numbers in order to get the parameter. And I just write P equals 3.82 plus 6 plus 4.64. And the final answer is 14.46, which could be approximated to 14.5. And this is the final answer. So let's just check. And the correct answer is 14.4 or 14.5, or somewhere between 14.44 and 14.46. The next problem is similar to the last one, but here we have a right angle triangle again. And we are told that the area of this triangle is 30 centimeters squared. So we are supposed to derive a quadratic equation. So now this is not exactly a Pythagorean theorem, but it's still right angle triangles. So how do we get the area of a right angle triangle? The area is half times base times height. So in this case, the area is 30. How did I know that the area is 30? Because they said right here, the area of the triangle is 30. And this is equal to half multiplied by the base, which is basically 4 times x minus 1, multiplied, it doesn't really matter what the base is and what the height is. So both of them would work. So here in my equation here, the height will be 2x plus 5. But of course, what I did doesn't really make sense, because just by looking at it, it just makes more sense to consider this the base and to consider this the height. It doesn't really matter. It won't affect the answer because they're all multiplied by each other anyway. So the important thing is to just multiply half times the first expression times the second expression. So how would you simplify this? This is the tricky part. You want to simplify this in order to arrive at the equation of A. Now, in order to do this, I'm just going to first multiply half by 4. And I don't need to distribute yet because these are multiplied by each other. You don't have anything plus or minus, so there's no distribution yet. So all you have to do is just cancel out the half with the 4, and you just get 2 instead of the 4. So now we have 30 equals to 2 multiplied by x minus 1 multiplied by 2x plus 5. What would you do first? Would you distribute the 2 first, or would you multiply the brackets, or would you divide 30 by 2? The smartest way to do this is honestly to get the 2 to the other side and just divide. You just do 30 over 2, because then you don't have to distribute the 2 and it's less work. So you just have 15 and you don't have that 2 anymore. And then you just expand these 2 brackets normal way. So x times 2x would be 2x power 2. And then x times 5 gives you 5x. And then minus 2x here. And then finally minus 5. So you get 15 equals 2x squared. 5x minus 2x gives you positive 3x. These two minus each other, that gives you positive 3x. And then minus 5. Finally, you take the 15 to the other side. Of course, you don't forget to change the sign. So you get 2x squared plus 3x minus 5 minus 15 equals 0. So 2x squared plus 3x minus 20 gives you 0. And we know that we are successful because this is exactly what they wanted us to arrive at. So question A is complete. Question B says use factorization to solve the equation 2x squared plus 3x minus 20 equals 0. So this particular question is good to remember that knowing, for example, the quadratic formula doesn't really save you from factorization. If you don't like factorization, you just need to practice, but you can't avoid it and just assume that you can use the quadratic formula instead, simply because they might get a question where they say use factorization. So you're just stuck with it here. How would we factorize this? So the important question to address here is, what are we looking for? We are looking for two numbers multiplied together, giving us the product of the first term and the last term, without the x's, of course. So 2 times 20 is 40. So I'm looking for two numbers multiplied together to give us 40. And their sum or difference has to give us the middle term. So is it the sum or the difference, first of all? So first of all, this depends on the sign here before the 20. If this is a minus, then we're looking for a difference. If this were plus, we would be looking for a sum. So what does this difference get us? It gets us positive 3. So we're looking for two numbers whose product is 40 and whose difference is positive 3. How would we find these two numbers? Some of you might like to do it mentally, and that's okay. But I would prefer that we do it systematically. And how would that happen? So first of all, I'll try to get the prime factors of 40 just to help me realize what the factors are. So 40 divided by 2 gives us 20. 20 divided by 2 gives us 10. Divided by 2 gives us 5. Divided by 5 gives us 1. Why did I do this? Just to give me an idea of what the number 40 is divisible by. So 40 is divisible by 2. It's divisible by 5. It's also divisible by 4 and by 8, because any number in this stick would work, and any multiple of these numbers would work. So for example, 2 times 5 is 10, so definitely 40 is divisible by 10, and so on and so forth. Next, we try to find the factors of 40 systematically. What do I mean by that? So we start by 1 times 40. And we do a check. Is the difference here 3? So the difference is not 3. So I just don't really care. The difference here is 39, basically. So we don't really care about 1 and 40. And then, is it divisible by 2? Yes, because we have 2 here, so it's divisible by 2. So 2 times what gives us 40? 2 times 20. But is the difference 3? Not really. So that's not it either. What about 3? 3 does not exist here. So it's not divisible by 3. So I just ignore the 3 and I move on. What about 4? Yes, it is divisible by 4 because we have 2 times 2. This is equal to 4. And actually, the other two factors will be the other number. So 4 times 10. Of course, you know that 4 times 10 is 40 anyway. But again, is the difference here 3? No, the difference here is 6 actually. We're looking for a difference of 3. So I'll just write the differences on the left so that you understand why they're wrong. 40 minus 1 is 39. 20 minus 2 is 18. 10 minus 4 is 6. So these are not correct. So is it divisible by 5? Yes, it is divisible by 5 because we have 5 here. And then the other number is basically going to be these three numbers here. And 2 times 2 times 2 is 8. So 5 times 8. And the difference between 8 and 5 is actually 3. So we are successful. This is the pair we want. I did it in a bit of a long way, but you could have mentally figured out that the two numbers we're looking for are 8 and 5, because 8 times 5 is 40 and 8 minus 5 is 3. Anyway, just in case you don't like doing things mentally, I like to take the longest route, just in case. So anyway, so the numbers here are 8 and 5, but 8 minus 5, of course. So basically, we have positive 8 and negative 5, and we start writing out our brackets. So how do we write our brackets? It's very simple. The way I do it is as follows. I just put in 2 brackets, and I take this term, but without the power 2. So I just write 2x here and there. And then I write plus 8 in one of them, and I write negative 5 in the other. And the final step is to simplify if possible. So for example, 2 and 5, just think of it like a fraction, 2 over 5. Can you simplify this? You really can't. So there's nothing to do here. But what about 2 and 8? If you have 2 over 8, this gives you 1 over 4. So you can simplify here, and this becomes 1x plus 4. So we have just x plus 4 times 2x minus 5 equals to 0. And they want us to solve by this method, not just to factorize. We just want to get the solutions as well. So x plus 4 equals 0, and 2x minus 5 equals 0. We just take each bracket separately. And here x is equal to negative 4. And in this case, 2x is equal to 5. So x is equal to 5 over 2. So our final answers are either negative 4 or 5 over 2. Both answers are considered right for question B, because this is not a real-life application. So I can take both values of x as plausible solutions. So x equals, just for completeness, x equals negative 4, x equals 5 over 2. Let's check our answers. And we are correct. Negative 4 and 2.5 are the correct answers. Now let's move on to question C. Of course, we have negative 4 and 2.5, but when we're calculating BC, we cannot take the negative 4. Remember, for B, the answers were negative 4 and 2.5. These were both correct for B, but for C, we can only take the positive because this is a real-world application, and you cannot have a negative value for x. So in this case, the triangle looks something like this. We have 4 times 2.5 minus 1, and we have 2 times 2.5 plus 5. In this case, we can just simplify. You can use the calculator or mentally or whatever. So this is going to be 6, and here you have 5. 5 plus 5 gives you 10. So we have a triangle that looks something like this. And we are required to find BC, which is basically x in this equation. Again, here we have to use the Pythagorean theorem. So all you have to do is just say x squared equals 6 squared plus 10 squared. If you don't understand where this came from, remember that the hypotenuse is the side opposite to the 90. And it's the longest side of the triangle, and we call it C. And then we call the other two A and B. And we write the Pythagorean theorem as C squared equals A squared plus B squared. So in our case here, we have x squared equals 36 plus 100. X squared equals 136. So x is basically the square root of 136. When you use the calculator, they didn't really specify whether they want an exact answer or a decimal. Doesn't really matter. You can just write both anyway. X is equal to root 136, which is equal to 11.66. And this is our final answer. Let's proceed to check if it's correct. So 11.66 is in fact correct, or even 11.7, that would have worked out as well. This brings us to the end of our video. Thank you for watching. I hope this has been beneficial to you.